Okay, so another rule that we have to obey is common denominators. So when you have a problem that is involving fractions, this will seem a little bit more complicated than some of the basic things we used to do with fractions. But think if you were going to add 1/2 and 1/3, okay? What would you do? You would multiply 1/2 by 3 divided by 3, and 1/3 by 2 divided by 2, getting the common denominator, which would be 6. Okay? This is the same concept. We want to get a common denominator so that we can combine our fractions together and get rid of that h on bottom. Okay? So, start off just like the other problems. This is going to be the limit as h tends towards 0. This is f of x plus h minus f of x divided by h. And it's just how we start on all the problems. This is the definition of the derivative. You might see it written different in some other ways, but they're all equivalent. So this would equal now the limit as h tends towards 0 of 1 divided by x plus h minus 1 divided by x, now divided by h. Now, I don't like 3-tiered fractions, so what I'm going to do is I'm going to pull this h to the outside of the problem, and I'm going to try to get a common denominator inside of this thing. So, this is going to equal the limit as h tends towards 0. This is 1 divided by h. Okay. Now, to get a common denominator, I'm going to have to multiply this guy by x divided by x, and I'm going to have to multiply this guy by x plus h divided by x plus h. Okay. So this is going to be x plus h times x minus, I'll do this with parentheses, x plus h over x, and then x plus h. Okay. And multiplication is commutative in this class. So it doesn't matter if I write it as x or x plus h, or x plus hx. So this is going to equal the limit as h tends towards 0, now 1 divided by h. All right. This is going to be x minus h divided by x plus h and x. And how am I getting minus x minus h? What I'm doing is I'm distributing this minus sign inside of this guy. So I'm just putting the minus on the x and the minus on the h. Okay, and then we can start seeing our cancellation that's going to occur. So the first thing to do, let's knock off the x and the x. Okay. So then we would have the limit as h tends towards 0, okay, this would be 1 divided by h, negative h, x plus h, and x. Right? At that point, h and h will cancel each other out. And so that would equal the limit as h tends towards 0 of negative 1 divided by x plus h and x. Okay, and so at this point, I can just plug 0 in right there. So what am I going to end up on the bottom of my problem? It's actually going to be x times x. Okay. Now, let's ask ourselves, does this make sense when talking about the power rule? Okay. Well, another way to think of this problem, I know I'm using power rule, I'm not allowed to, but we're just going to verify it. The derivative with respect to x of x to the negative 1, what's it going to do? It's going to spit out a negative 1, and then it's going negative 1 minus 1 would be negative 2. And that is the exact same thing as writing negative 1 divided by x squared. Because if you have a negative exponent, it's going to throw it to the bottom of the fraction.